Foundations of Amateur Radio. A couple of days ago, after months of anticipation, an unassuming little box arrived on my doorstep. Inside the box was a nondescript electronic device, with two SMA connectors and a USB socket. Other than the branding, there were no markings on the device, and it came without any instructions. It did come with a couple of SMA adapters, which came in handy. A little research later determined which of the two SMA adapters connected to an antenna and which connected to a radio. The gadget itself is called an upconverter. It's an interesting little device that essentially mixes two frequencies together, creating two new ones. Start with, say, 720 kHz and mix it with 120 MHz, and you end up with 120.72 MHz and 119.28 MHz. In other words, if you mix two frequencies together, you end up with both the sum and the difference of those frequencies. If you have a radio that can listen to 120 MHz but cannot listen to 720 kHz, then using an upconverter you can, as it were, expand the frequency range of your radio to hear different signals. I purchased the upconverter with the intent of connecting it to my Pluto SDR, since the lowest frequency it can do is 70 MHz. Combine the two and I should be able to listen to all of the amateur HF frequencies at once. Given that my Pluto SDR is currently doing something else, I had a look at using the upconverter with my Whisper Beacon monitor that uses an RTL SDR dongle. Technically it's not required since my particular dongle can be used to tune to HF frequencies, but as an experiment it works well enough. So I connected the antenna to the upconverter to the dongle, and the dongle to a Raspberry Pi, a single-board computer that runs Linux. Essentially the exact same setup I've been running for years, except that I inserted the upconverter between the dongle and the antenna. That and some power took care of the hardware. The software initially gave me some challenges. After discovering that the tool I'm using, RTL SDR Whisper D, has an option for an upconverter, I was up and running in minutes. So, at the moment, and for the next foreseeable little while, my Whisper monitor is using an upconverter to scan HF. Technically, this should increase the sensitivity by a significant amount, since the dongle is better suited to tuning to higher frequencies than it is to lower ones, but only time will tell. I updated my monitoring scripts to take into account if the frequency I was monitoring was out of range, so it currently won't report on anything above 60 MHz, but then that's fine for what I'm working on. I've updated the script on GitHub if you want to have a look. It's nothing fancy. It essentially checks to see if there's a file called upconverter, and if so, it calls a slightly different monitoring script. Given that I have existing logging data associated with this monitor, I should be able to discover if there's any significant difference between what I've been monitoring to date and what's coming in now that an upconverter is in the listening chain. Theoretically, I should be able to hear weaker signals, but time will tell. One thing that was interesting, whilst I was discovering how this all works and hangs together, is that it wasn't immediately obvious how to set it all up in software. I tried several tools to make sense of the data. In the end, the combination of GQRX, setting the local oscillator offset to a negative frequency, in my case 120 MHz, got me to the point where I could set the frequency to 720 kHz and hear my local broadcast station, whilst the software, actually, secretly behind the scenes, added 120 MHz to that and tuned the radio to 120.720 MHz. Once I got my head around that, things started falling into place. The same is true for RTL SDR Whisper D. Adding the upconverter flag with a value of 120 MHz got my monitoring station up and running. This is a pretty user-friendly way of getting started with frequency mixers. You might recall my exploration into components apparently made from unobtainium. The intent is to use a variable frequency to achieve a similar thing, but that's a project still on the drawing board. For now, I have a fixed frequency, 120 MHz, which is plenty to get started. If you're curious why I'd want a stable variable frequency, consider for example what might happen if you transmit from a HF frequency into an upconverter. Perhaps you could use your HF-capable Whisper Beacon to make a signal on 2 meters or 70 centimeters. 120 MHz won't cut it, but perhaps you can work out what's needed to get from the 10-meter whisper band to the 2-meter whisper band, or the 70-centimeter whisper band. I'm on it. Victor Kilo 6, Foxtrot Lima, Alpha Bravo.